Okay, so first of all, my name's Dan Waghorn, as Ryan mentioned. I'm the co-founder and CTO of a company called Junction London, and I'm really glad actually that Mark did a talk on DynamoDB, because what I'm about to show you is a good way to solve one problem, then break the database. So in order to deal with the capacity, you might want to have a look at DynamoDB. So let's start. My talk is on efficient workloads on ECS. So as I said, my name is Daniel Waghorn. Feel free to connect with me on LinkedIn if you want to. And the company Junction London is a little bit of an interesting one. So my background is in tech and always has been, but it's effectively the result of a merger between a brand and a marketing company and a digital agency. So the view we have around that is all the products that we use nowadays, you can have the tech, but if you don't have the product correct to the branding and the marketing, then it won't go anywhere. Or if you have a great product but don't have the tech to back it up, it will fail. So what we've done is, rather than be tech first and then brand and market second, or one way or the other, what we do is intersect two complete full service agencies in order to meet the customer need and deploy an effective and scalable solution. So here's just a cross section of the sort of services we offer. I'll not go into that because it's quite large, as you would expect. But an example of why we did Junction, I actually have a startup here called Mivia. So I'm a massive petrol head, and we had if you want to talk about this later, I'm more than happy to cover it, but we had a problem that we'd all found in the navigation space, and basically what we did was build a solution, a brand, launch it. We're really early stages, we're about 9 months in, and this is actually powered on AWS. And capacity, because we're quite data rich with the direction we're going in, is a huge underpinning in what we've done in terms of infrastructure. So let's get started. So what is ECS? Now ECS is Amazon Elastic Container Service. Now ECS is something that I would look at as more of an accessory to other Amazon services that you're already using or may be using. And it's a good sort of middle ground between some real sort of heavy enterprise solutions such as Kubernetes, and it makes some pretty advanced capabilities very accessible. So what is it? It's a fully managed container orchestration service by AWS. So what does that mean? It's providing a way to run applications. That could be a website, could be an API, it could be anything on AWS. Now, because it's containerized, these workloads need to be using Docker containers in this case, and it manages workloads on compute, which is provided to ECS. So ECS doesn't by itself provide any capacity to run your applications. You need to provide that, and there's a couple of ways you can do that, which we'll talk about in a second. So let's look at what that actually means. Now, this diagram is quite a good way of explaining this. So you'll notice there's two boxes. So at the top, we've got ECS. Effectively, what ECS is doing is a collection of sort of tools, an agent, and a couple of other things that run and manage the container lifecycle for your application. And then this bottom box here, it's customer-owned compute. So as I said, there's a few ways we can do this. So the most obvious one's EC2 instances that you're provisioning, so the small virtual servers. AWS Fargate, which is a sort of serverless solution for EC2, and on-premise as well. So you can actually install the ECS agent, which runs on these compute assets, and you could run it in theory on a data center, or you could run it on your own virtual private servers in another cloud. Not necessarily sure where you would want to, but it's quite flexible. And then within there, you've got your application running on the actual compute. So quick diagram what ECS is. So ECS, we're going to have to get a little bit of terminology out of the way just to get everyone up to speed if you've not dealt with this before. But ECS has a set of sort of terms which we need to cover. So the first one that we'll talk about is a cluster. Now a cluster, think of it as a sort of logical grouping of services or applications. We have a service, and then that service is underpinned with a task and a container definition. So let's have a little look at those in more detail. So the definition for a cluster is a logical grouping of related tasks or services. So you might traditionally think of a cluster as like a bundle of hardware. Because ECS doesn't provide any actual capacity, the logical way of dealing with this is think of it as just, if you have an application, you might have a cluster to run that application on, and that's the grouping of it within ECS. So it runs on compute provided by a capacity provider, and effectively what that is a definition which ECS uses to understand, right, where can I get the compute capacity to run what I need to run on. Can be provided with EC2 Fargate on premises we've discussed, and what it consists of is container instances which host the running task services. So if I've got 3 EC2 instances running, they would be my container instances. I could have Fargate instances for tasks, which we'll talk about more in a minute, or I could have on-prem service. Container instances is kind of the abstraction which doesn't consider how that's being provided. Now we have a service. Now a service is a collection of tasks which is run and managed by ECS. Now if I use, for example, an API as an example, I'd have a service for that API. So I might have my production API for an app. Now that service may have any number of tasks. Now think those tasks as individual instances of that application running on my ECS cluster. Now, the service kind of looks after the life cycle of everything that relates to how we provide that application, and it will manage the life cycle of the individual tasks. So think of a task as an instance of a running container. So if I spin up 3 copies of my API, I have 3 tasks running. Now, these can be also scaled, which we'll talk about at the end, to deal with capacity, and that's where ECS kind of handles the capacity requirements, and there's a few ways that we can do that. We'll have a task definition. Now, a task definition tells ECS how to run a particular task. So think of that as a blueprint for effectively how do I run my API. It also says how do I get the image, etc., that I need in terms of where does it live, where does it, what environment variables does it need, what parameters does it need. Apologies, those bullet points are actually the wrong ones. And to go and put this into context, a typical ECS deployment. So at the center here, we've got an ECS cluster. Now on that ECS cluster, ignore where that is running, we'll have a task. Now that task might be my API. Now the task is a Docker image which is running as a container. That will generally come from a registry somewhere. Most cases you'd use Amazon's Elastic Container Registry, and it will pull directly from there from ECS, place it onto the actual compute, and then boot it up. Now your users will generally access an ECS back service through an application load balancer. Now that basically simplifies the traffic that comes in. You can deal with a few things like SSL, etc., and expose it to the web. And then that application load balancer plays directly with ECS to understand exactly which container am I sending this to. Because ECS will manage, if I've got port 80 that my application listens on, because it could be a web service, ECS will assign that any port number, because each task will have an individual port number. That application load balancer there will broker the traffic to the correct task and kind of spread that incoming traffic across each of my tasks so that it can deal with it. Are there any questions on that so far? I'm conscious that we've covered quite a lot in a short space of time. And as Mark said as well, if there's anything that kind of pops to mind, please do put your hand up and ask. Okay, so let's move on from there. So what I'm going to do is I'm going to talk about ECS task placement. Now this is important to consider in terms of ECS. So despite being a managed service, it abstracts some complexity away, but in order to effectively and efficiently use it, you need to understand a little bit about how it works. So I'm going to use a container instance as an example here. So we've got an EC2 instance there, which is one running box that I can run a workload on effectively. Now, 2 things to consider. You might have, in this case, 16 gig of memory available on that instance, but there is an overhead that you need to account for with ECS. One, it naturally needs Docker because it has to run containers. So the Docker engine runs within that instance, but also there's the ECS agent which is driving Docker and starting and managing containers that runs on there. So of my 16 gig of memory, I might realistically only have, say, 14 to play with, as an example. But for simplicity, I'm not going to go into detail around that, and we'll keep the numbers round. So continuing with the example of a REST API running on ECS, what I've got is my Docker-based REST API, and if we say that this API generally requires 4 gig of memory and 1 virtual CPU unit. Now, because we've got 4 vCPUs and 16 gig of memory, if you think of the size of that task and its task definition, in theory, and I'll just ignore the overhead, you could fit 4 of them and leverage all the capacity in that agent. But there may be cases where if that used 8 gig of memory but 1 vCPU, so it's a memory intensive load, then I would use my memory, but I'm under provisioning on CPU. So something to consider here is try and right size your instances that underpin what you're running on it, as to not have capacity that you're not effectively using. So there's memory optimized EC2 instances available in AWS. So in this case, if it's a memory heavy task, you might want to lean to them rather than a more sort of general instance like a T4G or something. So what ECS will do, if I send a task into ECS or run a service on my ECS cluster, the ECS agent in AWS will look at what have we got available, and what it will try and do is it will try and run that task on what it deems to be the most appropriate place to run it. So if there isn't available capacity, ECS will throw an error back and say, I can't run it, and you need to do something about it. Otherwise, what it will do is it will try and spread the workload across the available capacity that you have. Once that's running, ECS will monitor the task. So you'll generally use a health check. So going back to the API example, I might have a health endpoint. ECS will poll that, and so will the load balancer, but we'll not go into that just now. And basically make sure it gets, I expect a 200 OK response to prove that that's still working. If it doesn't get that, effectively what it will do is it will then close that container down and restart it and try and bring it back up to health. And it will just continue to run that to try and maintain a fully up state. Now, if we look at task placement again here, we've got another example where the API still the same shape. We've got 4 gig of memory and 1 vCPU. Now, in this example, what I've got is 4 container instances that I can work with. So in production, in theory, what I can do is run 16 tasks of my API. So I could deal with a great deal more capacity than I could on the example here, because we'll have more available to us. Now, what ECS would do is distribute those tasks across each of these instances to try and saturate what we'll have available to us. So what are the advantages of EC2? So EC2, it underpins pretty much anything that you could need it to. It underpins RDS, it can underpin your own workloads, etc. Now, there's a massive array of EC2 instances available to you. Some are more optimized for different use cases, there's different generations, pricing, there's a lot to consider around it. So we've got full access to the virtual machine with EC2, so we can still access it as if we just provisioned it on its own, which can be important depending on your use case. And also with EC2, there's cost savings available if you want to do reserved instances or sort of spot pricing, etc. So you can get a little bit more creative about your cost models, which can be quite useful depending on your particular needs. Disadvantages with EC2 is you still have to manage the infrastructure somewhat. So you need to maintain these virtual servers. So that's something to consider. It's not a serverless service in this case if we use EC2. There's a little bit more complexity because you need to understand, right, where am I going to get the capacity from? And that's done through your capacity provider. And also you need to manage the fact that spare capacity may remain unused, which is potentially not ideal if you want to keep an eye on costs. There's also somewhat of a security overhead, and this is debated in my opinion. Basically, the way to look at it is if you're providing EC2, you're also responsible for it. So you need to make sure that the machine image is up to date and there's no security issues, as well as your container image. That point will become clear in a second when I contrast this against another option. So there is a serverless solution that we can use to provide capacity here. Sorry, on you go.
Yeah, so talking about the placement kind of, what are the best practices for scaling other application with ECS to handle unpredictable load?
I'll get to that in a minute. I've got a section on that, if that's okay. And then we'll kind of cover that, because there's a few things, and it will be dependent on what your specific needs in your workload are, but there's a few sort of ideas around it, and then if you've got any questions, we can have a chat if that works. Okay. AWS Fargate is an alternative to EC2 where the abstraction of, the EC2 provisioning is abstracted away. So think of it as serverless, but with virtual machines. Now, we don't need to worry about right sizing in this case, because if you think of these blocks on the right-hand side here, there are tasks, and basically what it will do is it will look at the task definition and provision exactly what that task wants, so it can remove that issue of right sizing. So you don't need to worry about the capacity overhead not being used effectively. So an advantage of Fargate, it reduces complexity. You don't have to manage the capacity provider. You just provide a task definition to ECS, and AWS will provide it. It's less maintenance because you're only responsible for the image in this case. You don't have to worry about the hardware or machine or anything like that. As I mentioned, no need to right size. You don't really need to do any setup. So if you're provisioning your infrastructure using ECS, it does take a fair chunk of code out of your infrastructure as code. And it's well suited actually for, I'm going to go back to this case here. I've got 4 machines here. If I'm running an API, I have the API that serves requests. That needs to run all the time. But as part of that deployment, I might have a database to migrate. Now that migration might only last a minute or two. So to fit it in there, I need to then have space to put that migration task and run it. And then when that task ends, there's a gap that doesn't get used until the next deployment. So that's capacity that I'm not leveraging effectively. But with Fargate, what I could do is run my actual API on EC2, and this is something I personally do quite a lot. And then for the migration task, run a Fargate deployment that runs for 2-3 minutes, migrates the database, and then disappears. So that's why it's quite useful for sort of short-lived tasks or scheduled tasks that don't run all day long. So it's a good alternative to mix in here. Disadvantages with Fargate, there's not many, but it can be quite expensive. So in my experience, if you wanted to use Fargate to run a perpetual task like an actual API that's serving requests, generally can be quite a lot more expensive than EC2, especially if you look at reserved instances and other cost-saving measures. Depending on your workloads as well, something that's becoming more and more important if you're running a sort of ML workload or anything that's using AI, you might be using a GPU. You can't use GPUs with Fargate, certainly at the minute, so just something to consider. And it actually can't run privileged containers. So if you've got a container that requires root access or needs to do something quite tightly integrated with the host, you can't do that on Fargate for obvious reasons, because the hypervisor is kind of security boundary in that case. So, as I said, consider a hybrid approach. You can mix and match where your capacity comes from in an ECS deployment. So an effective way of using ECS is use EC2 if that suits your workload for sort of the perpetual tasks, and then for the more ad hoc things or just running maintenance, and even if it's short-lived or even sort of longer-lived and you want to just experiment to abstract complexity away, Fargate's a good option to consider. So you've got 2 tools in your arsenal, and the only thing that needs to be changed in order to use both is a small change in the task definition. So your capacity provider, you'll have a launch type. It's either EC2 or Fargate, and it's as simple as that. So what it boils down to is there really is no sort of one trick for all. So carefully consider your use case. Different workloads have different demands, and this is where, as sort of cloud engineers, we kind of earn our money. So try something, see what works, analyze how well it works, and then make changes as necessary. So the other thing that I want to talk about, which brings on to your point, auto-scaling, this is where I think ECS really comes into its own. So want to scale effectively. Now, this is a little bit more of an embellished diagram compared to the one at the start, but it's still effectively the same thing. So we've got a user here, hits a domain name that goes into a load balancer. So that's our application load balancer. Then what we'll have here is we've got our application which lives in a container registry. Docker image is pulled by ECS, gets its task definition to know how to run it. And then what that does is it will feed it into an auto-scaling policy. Now that auto-scaling policy controls how many tasks get provisioned within our cluster. And the way that that works is you'll generally have a maximum number of tasks that you want to run just to control cost. Imagine you got DDoS, you could end up with a big cloud bill. So you want to create some sort of limits, but also you have a minimum on that, which is basically your sort of residual capacity for downtime, or sorry, not downtime, but like quieter periods, so that it's always available. And then beyond that in the middle, you can scale based on load. And what that does is that works with an auto-scaling group. And think of that as Mark mentioned, you start off with say 3 nodes, or in our case, container instances, and then that will scale up and add capacity as needed. The difference with this compared to DynamoDB is as this sort of reduces in terms of traffic, it will scale back in as well, which is a direct correlation on your cost. So just bear in mind that costs will vary based on traffic, but you're not ever going to be in a case, provided it's tuned correctly, that you're paying for capacity you don't need. So it can be really quite an effective tool in terms of managing cost. So just in terms of managing cost here, what we have here is, if you look at this diagram, imagine you've got a big server running somewhere to deal with a website that gets big spikes in traffic and deals with that capacity. But then either side of that peak here, you've got all this wasted overhead. Now, a little anecdote, we had a customer come to us and they had a website that kept going down. It was e-commerce during big traffic. So they couldn't actually scale anymore because it was running on a VPS provider, shall we say, and the company before couldn't move the slider any further. So they were paying massively for capacity that wasn't being used 99% of the time, which was a huge cloud bill. So we put a solution in place actually using ECS that deals with huge peaks of traffic that keep growing because they're growing as a business, but then actually reduce the cloud bill because it's not paying for capacity where it's not being used. So what we've got here, if you look at the green line, that's sort of your residual capacity. So you always want to have a bit more provision than you need. And then the blue line there is your amount of traffic. The difference is when there's not traffic there, we're not carrying that red line there, which is having all this capacity. So that's kind of the aim of the game if we're looking at auto-scaling here. Now, the way that we can do this is obviously with auto-scaling groups. ECS is designed to work predominantly with this from the ground up. So it's dead easy. What we're talking about here is horizontal scaling. It doesn't do vertical scaling, but you could, if you wanted to add less instances horizontally, you could run potentially bigger instances so that you've got that vertical element, but ECS won't size the instances more. You could do something really complicated, which I don't understand why you would, if you can do it horizontally and have like different strategies and say, right, when we get to a certain level of traffic, we're going to put like large instances instead of mediums. Depends on your use case and how you forecast that spike in traffic. So you have a lot of flexibility with it, but in most cases, the best thing to do would be just look at it horizontally, have a decent instance, and also build enough overhead in it so that while these other instances come online, you can still absorb that increase in traffic. Otherwise, you're going to end up sort of hitting ceilings as it scales. So again, the capacity provider gives ECS a means to add and remove capacity as it needs. Now, the way that this is generally done with ECS is through CloudWatch metrics, and then you use CloudWatch alarms which say, right, we need more capacity or we don't need more capacity. So the way that we generally do this, it depends on the workload again, generally CPU or memory would be the two main metrics as to do we need more capacity. So you have two alarms. You'll have a high alarm which will trigger a scale out and says to ECS, I need more instances. And then you'll have a low CPU alert, which once that spike's passed and everything kind of calms down, says, right, we don't need this. And it will keep pulling instances out until it either gets kind of in the middle of these two, or it will hit your minimum capacity. So depending on how you tune it will determine how much capacity you have at your disposal. So to summarize what I've pretty much just said there, that's how that works. You could get a little bit more clever with this, but like I say, CPU and memory is the main ones, but if you had a really disk-heavy workload or some other sort of network-intensive workload and you find that you're saturating the throughput on the network interfaces on your instances, you might use that as a metric, but it just depends. You can create the alarms and the criteria, and you could also use a combination. So you could set memory limits, and you could set CPU, because even though you've got an API, there might be some endpoints that use more memory because they're processing data, and you've got other endpoints that are sort of not memory intensive, but CPU intensive. So it depends on how it works for your particular case. And again, ECS will control how we place the tasks. And as we mentioned at the start, that load balancer kind of does a lot of the heavy lifting in terms of complexity. So you just send your users, they hit the load balancer, and that'll try and distribute the traffic across the instances, and ECS will do some clever stuff to figure out which instance is quieter and try and even the load. Again, absolutely essential, make sure you put limits on your sort of scale out, just so that you can control costs, just in case something bad goes wrong or a CloudWatch alarm could not be set right, and you could come back to 1,000 EC2 instances running that you don't need to and quite a big bill. So just always put a cost control in place, which is good practice for pretty much anything you do with clouds that scales. And also understand your workload. So the way to do that is, first of all, break it. So go and run a load test and see what falls over. If it is the front end and the web layer in this case, then that's where ECS comes into it. Eventually, you're going to chase other bottlenecks when you solve issues. So it might, generally, once you solve this, it's going to be the database that will fall over in a lot of cases. It may be file system storage with sort of individual operations, and you just need to chase these things through. But in the case of ECS, understand, right, I'm running a load test, I'm looking at my metrics, what's causing the capacity issues? My CPU going high, okay, I might use CPU as my metric for when I want to scale in and out. Then what you want to do is try and implement a strategy, and in the case of, right, CPU's going high, okay, once we sort of hit an average of 60% CPU potentially, we want to start scaling in, or sort of scaling out for more instances. And then what to do is also consider schedules. So if we look at CloudWatch metrics, that's one way of dealing with things, but that's reactive. If we've got some sort of workload that is something that we could sort of forecast, so again, e-commerce example, I know Mark, you use that one. We're coming up to Black Friday, so let's put some capacity in, knowing that, right, sales are going to go live, and just kind of preempt it, just so that you can minimize the risk of downtime if that spike's really steep. Because if it's quite sort of shallow, then you've got plenty of time to provision instances. But these do take time, so you want to just try and mitigate against capacity not coming in quick enough. And then also, just look at the use case, and that extends beyond the tech side of it. You need to understand exactly the model, the commercial aspects of it, and external factors as well. And then once you've got your minimum sort of capacity for your workload, that sets the baseline. So you'll never scale in more than that. That will give you your sort of baseline cost. And in an ideal world, if you don't need to scale out, it's a predictable cost. Also consider, if you were at 100% capacity for a full month, that is the upper limit of what your theoretical cloud bill would be, and just use that as a way of roughly estimating things so there's no nasty surprises. And then also, as I mentioned, put a margin of overhead in. So I said the example there of CPU scale out 60%. Sounds a little bit low, but if these instances take 2 minutes to start up and then come in and come online and then actually join the load balancer, by the time those 2 minutes are up, I might be up to 80%, at which point things start slowing down. So you don't want to start scaling in at say 90% because you might then start to drop users or not be able to respond to them, and it's not, you're just running it too close to the bone. Also, implement observability. So it's one thing solving the problem, it's another thing making sure that it's solved, and also making sure that you can see, right, that'll be the next bit that falls over. So don't let your users tell you something's gone wrong. Try and preempt it and think, right, we can dial this up a little bit, or the database is getting tight, or we're saturating certain resources. And then finally, run load testing to try and validate. So if you have a way of managing, right, 50,000 simultaneous users, that's what we reckon might happen. Let's try and run a load test for 60 and just validate, okay, that looks good. Obviously nothing's 100% guaranteed because it's quite actually a difficult thing to do accurately in terms of load testing, but you need to validate. It's effectively like unit testing your code. You need to test your infrastructure as well. So to conclude, ECS on AWS provides a really robust solution for managing containers and managing that across compute capacity. And it's got a lot lower barrier to entry than solutions like ECS or Kubernetes or some of the more heavyweight solutions. It's a really good sort of low tariff buy-in option to have some real quite powerful capacity available to you. Also provides fault tolerant, scalable and reliable deployments. So I didn't really talk about deployments, but what AWS will do is if I deploy a new version of a container, it'll keep my existing ones up, bring up the new ones and start to switch traffic across. So you can do zero downtime deployments with it, which is something that's really useful, especially depending on use case. And then also you can tune the task definitions and experiment with things and make sure that your infrastructure is engineered around your use case. So you can really optimize what you're doing in terms of cloud, which is not necessarily so easy with VPS because you just put something on it and kind of try and use it as best as you can, whereas this can get really quite granular and you can set hard and soft limits on certain things. Okay, so that's a whistle-stop tour of ECS. There is an awful lot more to it, but if anyone has any questions, then feel free to ask, or more than happy to have a chat just at the end of the event tonight. But thank you for listening.
Questions? That is like really strong. Like you have a rich experience. Like I can see from sharing when it's like do this, not do that.
I have made a lot of mistakes in the past, and that's the best way to learn. But the trouble is, they can be quite expensive if you don't manage the risks. Now, thankfully, I've not had any of those, but just anything with autoscaling, my advice is just always set a limit on it. And then just create the guardrails and then go and experiment, because it can be really quite interesting. And, I'm a big advocate of, software is all compounded. So you want to make sure that your application's performant within the container. And then once the container runs, you want to make sure the infrastructure's performant and enables it to run its best. So by sort of applying best practices all the way from sort of function level optimization all the way to how quickly can we deliver data to users across regions again, it all makes a huge difference. And the reality of it is we're in a world now where people are more impatient than ever. Like they want sub-quarter of a second responses. So this is one of the ways that you can achieve that and also try and keep the lights on. We're in a sort of era now where within reason, I don't think there's really much excuse for ever putting a queue in front of a website and making people wait. So I'm not sure why Ticketmaster still do it. But also, you have all this stuff available to you at a very relatively small cost, and even a small startup can build web scale applications with relative ease. And it's tools like this that enable you to do it. And, DynamoDB, again, I've used it a couple of times, probably not lent on it as hard as I could, but everything is available there to create some really quite exciting and performant solutions.